Everything you're about to see is pure imagination. It's not real technology, and it's not a set of instructions. In the imagined conflicts of the future, the role of reconnaissance may no longer belong to humans or traditional drones alone. Instead, it may fall to compact autonomous machines designed to move with quiet precision, think independently, and navigate environments far too unpredictable for conventional platforms. One such conceptual system is the Q-4 Sentinel, a four-legged autonomous recon unit created not for combat but for presence, a silent observer built to survive and adapt. Its compact frame hides a dense array of multi-spectrum sensors, gyroscopic stabilizers, and low-signature mobility joints that allow it to traverse debris, ruins, or narrow structural corridors with ease. The Sentinel does not chase conflict, it studies it. It does not overpower threats, it simply outlasts them. In this imagined future, machines like the Q-4 do not behave like robots, they behave like creatures of the environment, blending into dust, rain, or shadows. The Q-4 Sentinel represents a shift in how reconnaissance could be understood, not as surveillance from above, but as quiet movement through the world at ground level, where every vibration, every temperature change, and every pattern in motion tells a story only a patient, persistent machine could read. The imagined Q-4 Sentinel was created around a simple but powerful idea. A machine is only as capable as the environment it can survive. Rather than being built as a weapon or a mobile turret, the Sentinel was conceived as a ground-level intelligence node, something small, stable, and persistent enough to gather information where aerial drones cannot reach. Its four-legged configuration is not inspired by animals, but by physics, a platform that distributes weight equally, maintains balance under shifting loads, and moves with deliberate precision on uneven terrain. The structural core of the Q-4 is a reinforced monobody shell crafted from a fictional composite called tricarbon alloy, a material imagined to be light enough for rapid motion, yet dense enough to dampen vibration. This shell houses the Sentinel's central processor cluster, a tri-layer stacked cognition module that allows it to run environmental mapping, threat pattern prediction, and self-stabilization routines simultaneously without overheating. Around the core frame, micro-actuated armor plates shift gently to absorb impacts or deflect debris, not for combat protection, but to ensure the machine remains functional during long-term field operations. Each of the four legs contains a set of adaptive microservos, allowing movement that feels less robotic and more organic, controlled but flexible, precise without being rigid. These servos work with gyroscopic stabilizers embedded in the hip joints, enabling the Q-4 to navigate collapsed structures, stairways, tilted surfaces, or soft soil with equal efficiency. Its gait is algorithmically modulated, slow and quiet for observation, wide step for traversal, compact and anchored when scanning or recording. At the front sits a single all-purpose optical module, the Sentinel's eye. While simple in appearance, this lens is supported by a fictional omni-band sensor array, capable of analyzing thermal patterns, motion vectors, acoustic signatures, and atmospheric traces simultaneously. The lens can rotate independently of the body, giving the Q-4 a full 270-degree field of environmental awareness without the need for constant repositioning. The design philosophy behind all of this is restraint. Nothing about the Sentinel is aggressive, flashy, or large. It doesn't project dominance. It disappears into its environment. Its real power comes from endurance, small energy-efficient processors, low signature mobility, and modular sensor pods that can be swapped depending on terrain. The Q-4 isn't meant to win battles. It's meant to read the world, quietly, patiently, endlessly. In the imagined future, the Q-4 Sentinel's most defining trait is not its mobility or durability, but the quiet sophistication of its sensor architecture. Designed as a ground-level observer, the machine is built to read the world through layers of signals that humans often overlook. At its core is the omni-band sensor array, a fictional multi-channel system that fuses optical, thermal, acoustic, electromagnetic, and particulate data into a single unified perception model. Rather than relying on brute force scanning, the Q-4 focuses on subtle environmental cues, minor temperature gradients, pressure inconsistencies, vibration residues, and micro patterns of motion that paint a deeper picture of its surroundings. The Sentinel's primary lens, mounted at the center of its front chassis, houses a set of rotating crystalline filters imagined to adjust in milliseconds to changes in light or heat. This gives the machine the ability to transition seamlessly between high-resolution visual mapping, long-range infrared tracking, and tight-spectrum thermal contrast. Beneath the lens, a narrow acoustic aperture analyzes frequencies far beyond human hearing, allowing the Q4 to detect distant footsteps, shifting metal structures, or drone rotors long before they come into sight. On each of its four legs, micro-resonance sensors monitor ground vibration patterns with remarkable sensitivity. Through this, the Q4 can feel movement, not as sound, but as physical signatures traveling through soil, concrete, or rubble. It can distinguish between a falling piece of debris, an approaching vehicle, or even wind interacting with loose surfaces. These sensory layers are constantly cross-validated through an internal behavior engine known as the pattern recognition core, enabling the Sentinel to form predictions about environmental changes moments before they occur. Behaviorally, the Q4 Sentinel operates less like a robot and more like a cautious animal. Its movements are slow and deliberate when the surrounding environment is unstable, but fluid and efficient when the path ahead is clear. When encountering unfamiliar spaces, it performs a three-point environmental check, scanning thermal drift, reading acoustic feedback, and sampling air particles for chemical traces. Only after reconciling the data does it proceed, often adjusting its posture or gait to reduce noise or avoid creating detectable vibrations. The machine does not speak, but it observes, constantly and elegantly. When stationary, the Q4 lowers its profile, shutting down all but essential sensors to blend into the environment. In this dormant observation mode, it becomes a silent node, recording data and waiting for anomalies. When active, it communicates non-verbally through encoded light pulses along its chassis, transmitting information to other units or relay stations without revealing its position. In this imagined future, the Q4 Sentinel embodies a unique blend of machine precision and creature-like awareness. It does not dominate the battlefield, it interprets it. It navigates not with aggression, but with patience. A quiet intelligence built to see what others miss, to move where others cannot, and to understand the world at a depth typically reserved for intuition rather than machinery. In this imagined future landscape, the Q4 Sentinel is not conceived as a frontline war machine, but as an adaptable intelligence asset, a ground-level explorer capable of operating in environments where aerial drones or human scouts would struggle. Its versatility begins with its mobility. With four legs capable of fine-tuned articulation, the Sentinel can navigate collapsed structures, flooded corridors, narrow industrial tunnels, unstable cliff edges, and dense forests where GPS signals or aerial visibility might be compromised. In this sense, the Q4 becomes a bridge between terrestrial and subterranean reconnaissance. One of the most compelling imagined applications lies in post-disaster assessment. In collapsed buildings or earthquake zones, the Sentinel's compact frame and vibration sensors allow it to move quietly through wreckage, while identifying structural weaknesses, trapped survivors, or chemical hazards. Unlike flying drones, which rely on line of sight and stable air currents, the Q4 can physically reach areas that are obstructed, dusty, or cut off from external communication. Another role involves environmental monitoring in high-risk zones. The Sentinel's omni-band sensor array makes it ideal for scanning volatile atmospheres, tracking temperature gradients near volcanic activity, or mapping shifting subterranean gas pockets. Its chemical and particulate analyzers can collect data without exposing human researchers to danger. Over time, the Sentinel could form a network of autonomous ground-based observatories, quietly recording long-term environmental changes. In an imagined security context, the Q4 functions not as an attacker, but as a low-profile perimeter intelligence node. Its low acoustic signature and ability to blend into terrain allow it to remain hidden while monitoring motion patterns, electromagnetic signals, or structural vibrations. The machine's patient vigilance makes it a reliable companion for facilities requiring constant, silent oversight, from remote research outposts to underground data archives. Perhaps its most advanced speculative application is in machine-based ecosystem interpretation. The Sentinel's sensors could pick up micro shifts in animal behavior, environmental rhythms, or weather cues, forming a layered understanding of natural systems that would be difficult for humans to perceive. Over thousands of operational hours, it might develop a form of environmental intuition, a machine's version of instinct that allows it to predict changes in its surroundings with uncanny accuracy. In deep exploration missions, the Q-4 Sentinel becomes a solitary pathfinder. On distant worlds, crater interiors, unlit tunnels, or abandoned infrastructures, its quiet movement and durable frame make it a natural candidate for extended unmanned expeditions. It is not fast, nor particularly strong, but it is enduring. It waits, it listens, it learns. The imagined future usefulness of the Q-4 Sentinel does not come from dramatic action, but from its ability to turn silence into knowledge, gathering data patiently, step by step, in places where no other machine can tread. The imagined Q-4 Sentinel earns its place in future reconnaissance, not through intimidation, but through balance. Its strengths are subtle, the kind that matter when silence, endurance, and sensory precision shape the outcome of a mission. At its core, the Q-4's greatest advantage is its ground-level situational awareness. While aerial drones offer speed and elevation, the Sentinel understands terrain intimately. Its four-legged platform allows it to maintain stable contact with the ground, reading vibrations, microtextures, and structural tension in ways flying sensors cannot. This makes the Q-4 exceptionally effective in dense environments where airborne visibility drops to zero. Another strength lies in its low acoustic and electromagnetic profile. By design, the Sentinel produces minimal noise, heat, or radio emissions, enabling it to move and observe without revealing its presence. Unlike larger mechanized systems, the Q-4 does not stand out. It disappears. Its small frame and energy-efficient mobility allow it to operate for extended periods without generating detectable patterns. This grants it endurance, making it particularly suited for long, passive missions where patience is more important than speed. The Q-4's sensor fusion capabilities are also a defining strength. The omni-band sensor array and pattern recognition core allow it to interpret complex environments from multiple angles at once, thermally, acoustically, chemically, and visually. This multi-layered perception enables the Sentinel to detect anomalies long before they become threats or challenges. It can sense unstable structures, hidden cavities, or subtle atmospheric changes that would escape conventional equipment. This makes the Q-4 invaluable for scientific expeditions, hazardous terrain mapping, and post-disaster operations. Yet despite these advantages, the Sentinel has conceptual limitations. Its mobility, while adaptive, is not fast. The Q-4 is built for endurance, not rapid response. In large open spaces or scenarios requiring quick repositioning, faster aerial systems outperform it. Its compact size, though useful for navigation, limits onboard power storage and prevents the integration of advanced propulsion systems. Additionally, the Q-4 is highly sensitive to ground instability. Environments such as shifting sand, loose gravel, or deep mud reduce the effectiveness of its vibration-based sensors. While it compensates through thermal and optical inputs, the loss of tactile clarity diminishes the accuracy of its predictions. Radio-dense or electromagnetically active regions can also cause temporary sensor desynchronization, forcing the machine to rely on backup routines that are slower and less adaptive. Its final limitation is a conceptual one. The Q-4 is a listener, not a responder. It gathers information exceptionally well, but is not designed for intervention. It cannot stabilize structures, extract objects, or survive heavy force. Its purpose is insight, not impact. In this imagined future, the Q-4 Sentinel's strengths and weaknesses form a deliberate equilibrium. It excels where awareness and patience matter most, and falls short where speed or force dominate. A machine built not to change the world, but to understand it. In the imagined world of future reconnaissance, the Q-4 Sentinel represents more than a machine. It stands at the intersection of presence and absence, a device designed not to dominate a landscape, but to disappear within it. Its quiet gait, low signature sensors, and patient behavioral logic reflect a different philosophy of technological advancement, one where strength is measured not by power output or armor thickness, but by the ability to understand an environment without disturbing it. The Q-4 is not a soldier, nor a drone in the traditional sense. It is a listener, a watcher, a quiet interpreter of the natural and artificial patterns that make up the physical world. What makes the Sentinel compelling is how its imagined capabilities reshape the role of reconnaissance. Instead of replacing human scouts or aerial drones, it fills the gaps they cannot. Where humans hesitate, the Q-4 steps forward. Where drones flutter in unstable air, the Q-4 remains grounded. And where data becomes chaotic or incomplete, the machine's layered sensor architecture provides clarity. In this way, the Q-4 embodies a kind of technological humility, a willingness to learn from its surroundings rather than impose itself upon them. Philosophically, the Q-4 raises questions about the future of autonomous machines. If a device is built to observe without interfering, to listen rather than act, does it become more akin to a scientific instrument or a living creature? Its cautious movements, environmental checks, and adaptive posture blur the line between mechanism and behavior. Over long operational cycles, one could imagine the Q-4 developing a form of environmental intuition, a subtle awareness derived not from emotion, but from repeated patterns sensed and stored across thousands of missions. Yet the Sentinel's imagined limitations are part of its meaning. It is not built for force, and it does not attempt to be. In a future where machines often escalate conflict, the Q-4 represents the opposite, a shift toward intelligence before action, observation before interference. Its existence suggests a future where technological progress might favor subtlety over spectacle, where the machines we rely on do not shout into the world, but study it in silence. In conclusion, the Q-4 Sentinel's envisioned purpose is not to reshape battlefields, but to illuminate them. Its role is to bring understanding to the edges of the unknown, ruins, frozen corridors, deep forests, distant planets, anywhere visibility fades and complexity rises. It does not change the environment it enters. It simply reveals what was already there. And in a world increasingly defined by noise, the Q-4's quiet persistence feels less like science fiction and more like a necessary philosophy for the future. Sometimes the most powerful presence is the one that listens. If you have ideas of your own, feel free to share them below. Thank you for watching.